Hello everyone, my name is Aryav and today I'll be presenting an introduction to software for the 2024 to 2025 FTC season. In this presentation, I'll be going over an introduction to FTC software, odometry, and types of hardware, the FTC SDK, and setting up Roadrunner, MeetMeep, and RRPathGen. Here are some basic terms that are needed when talking about FTC software. First is the autonomous period, which is the first 30 seconds of the game, where the robot is controlled by pre-programmed instructions. The teleop period is the remaining 2 minutes where the drivers will be using their controllers. Sensors are the input of the robot, and some include the camera, distance sensors, and odometry sensors. The motors and servos are the output of the robot that control the different mechanisms on the robot, such as arms, claws, slides, and more. Now I'll be talking about software and libraries used for FTC. In FTC, you can choose to do either block coding or use Java. We highly recommend using Java even if you are just starting, as there are numerous different open source libraries that can help a lot in Java programming. The libraries can reduce the amount of coding needed. For example, using the FTC SDK allows us to run the motors and servos on our robot, along with receiving input from different sensors. One aspect of software that almost all teams use is odometry. Odometry is the use of sensors to determine the robot's position and velocity on the field. These sensors include drive encoders, dead wheels, and optical sensors. We will go over these sensors in the next slide. There are many different types of odometry that can be used depending on the game field. The first and most common type of odometry is dead wheel odometry, which uses 2 to 3 dead wheels to track the robot's position. Another more compact solution is optical odometry sensor, which uses a laser to track the robot's position, just like a computer mouse. Next is a distance sensor odometry, which uses distance sensors that can calculate the robot's position based on how far away it is from the field walls. Lastly is vision odometry, which uses a camera to detect the April tags around the field to find the robot's position. Here are some of the hardware requirements for odometry. Starting off with the most common dead wheel odometry, there are multiple options such as GoBuilder odometry, optiodometry, or custom options such as OpenOdo or LuniOdo. These odometry sensors must be sprung down using a spring or rubber bands, ensuring that there is traction between the floor and the dead wheel. Moving on to optical sensors, the SparkFun optical tracking sensor must be mounted precisely 10 mm away from the floor tiles for accurate tracking options. Distance sensor odometry requires 2 distance sensors to track the X and Y positions of the robot and the IMU for heading. Vision odometry requires 1 or more cameras, such as Logitech or ArduCam cameras, to sense the April tags. Now I'll be talking about the FTC SDK. The FTC SDK is a software development kit that first provides and allows teams to control the different motors, servos, and sensors on the robot. This SDK can be found on GitHub using a link in the description of this video and can be cloned into your own team's repository using GitHub. The FTC SDK also contains sample op modes that can help teams learn new skills, such as using April tags, which is useful for odometry, bulk reading, which lowers down loop times, and controlling LEDs for driver enhancements during the teleop period. Now I'll be talking about Roadrunner, which is an open source library that our team found very useful in the past 3 years. Roadrunner is a motion planning library that can be used for odometry to follow predetermined paths. Roadrunner is extremely useful as it allows you to create complicated splines that can be followed accurately, quickly, especially if there are a lot of obstacles on the playing field. There is also a built-in simulator called MeetMeep that can allow online visualization of these Roadrunner paths before you test it on a physical robot. Next, we will be going on to a hands-on activity for getting started in programming a basic robot and setting up Roadrunner, RRPathGen, and MeetMeep to generate and visualize your own paths. Okay, so now we're going to get started with our hands-on activity. So step 1 is to download and import the FTC SDK. So here's the FTC SDK, and just to let you know, some prerequisites to this is that you need to have Android Studio installed. So you can download it from this link, which will also be in the description. And then there will also be Java at a minimum requirement of Java 8, which you can download from Oracle. You will need to create an account for this. So please have that installed. You can like pause the video and visit the links in the description if you don't have these already. So the next thing we're going to do is we're going to download the FTC SDK. So you can get this from the GitHub link, which will also be in the description. And essentially, this is the software development kit that first provided. And this allows you to control all the motors, servos, and sensors on the robot. And it also allows you to install Roadrunner and Mimip as we talked about before. So in order to install this, you go to the green button called Code over here, and then you can download it as a zip file. So now that you see it's installed, you can open it in your file explorer over here. And what you're going to want to do is you're going to want to extract all. So then you'll get a window like this, and you can just press extract. So now you can see it's extracting. And there we go. So now we have our FTC SDK installed. And now what we're gonna want to do is we want to open this in Android Studio. So you can get your Android Studio up and running, and then you can open a new file over here. I already have some repositories open, so you can just press open when you get to Android Studio. And then what you're gonna want to do is you want to find out where it went. So mine's went to my downloads folder, and then it is called FTC Robot Controller Master 1. And so mine's alphabetically sorted, so over here. And what you're going to want to do is you want to open the folder first, and then you see, if you see like a file with like a green like Android icon next to it, that's the one you're going to want to open. So click on that and press OK. And then you'll get something that says like this. And if you already have Android Studio and other like repositories open, you can press new window, or this window if you don't have anything else open. And then you're going to get something like this, and it's going to say trust project, and you just click trust project. And then you'll get something like this, which will open. So right now it's going to be like Gradle building. And then you're just going to want to wait till that finishes. But by that time, while this is Gradle building, what we want to do is that we want to actually install something called Roadrunner, or the Roadrunner Quick Start. So what you're going to want to do is you want to go to this link that's also in the description. This is essentially the installation guide to Roadrunner, and we're going to be using Roadrunner 1.0. So what we have to do is that you're going to go to this GitHub page, or I already have it open, so just click on that and you'll see this Roadrunner Quick Start. So what we want to do over here is that we actually want to download this as well. So what you want to do is you want to download zip, and then it will go inside your downloads folder. And then you're going to want to open this and then extract this as well. So yeah, same thing, we extract and it'll finish extracting. And then you have this. So you actually do not want to open this in Android Studio yet. So let's just go back to our Android Studio, and you see that this is completely built. So that's good. And then this is where your code is located. So you have two folders, FTC Robot Controller and Team Code. So your code is going to be in the Team Code, and then you want to go to Java, and then all of the code that's on your robot will have to be here. So you can like right click on this and open new Java classes. And like this is essentially the files on your robot, your different autonomous and teleop like programs. So first what we want to do is we actually want to set up Roadrunner. So let's go back to this instruction pages. So first we want to open the team code build.gradle file and add this. So I'm just going to like copy this first. And then when we go to our Android Studio, if you see Gradle scripts, you want to open that. And then you should see one that says team code. So this is a build.gradle file, and then there's team code over there. So you want to open this file, and then what we want to do is that we want to see what it says in the file add between the Android and dependency blocks. So let's open that again. Android and dependencies. So what we want to do is we want to press enter, and then we will paste that in. Okay, next what it's asking us to do is we want to put this implementation at the end of the dependencies block. Okay, so we're going to copy that. And then at the end of the dependencies block, we're going to put all of this in. And the most important thing you want to do now is that you want to do a Gradle sync. So in a Gradle sync, you want to press sync now. And this is essentially going to install all these libraries that Roadrunner requires. So now that that's done, so next what we're going to want to do is that we already installed the Roadrunner, we already downloaded the Roadrunner zip, and now we want to go into our file explorer where we extracted it. So over here, and then you want to go here, open it, go into team code, go into source, main, Java, org, first inspire the FTC.team code. And all of these files, you want to like copy them. So we select all of them and we are going to press copy. Okay, now you want to go to where your a robot controller, the SDK that we downloaded, and you want to go here into this. Oh, my bad. You want to go here and then you see team code over here. And then source main Java org.first inspires FTC.team code. And the only thing here is a README. So now what you want to do is you want to paste everything that you copied from the Roadrunner Quick Start, and now it pasted all over here. So now if we go to Android Studio, all of these things showed up in Android Studio as well. So that means we now have Roadrunner installed inside our repository. So the next thing we're going to do is on the slideshow, we are going to create and download and import the FTC SDK. We already did that. And now we're going to build a basic FTC robot class. So in FTC, we try to create a class called a robot class, which controls all our motor functions and servos, and it also initializes everything so that we don't have to like do it every single time we make a new program. We can put everything in one file and call that class in all of our autonomous programs, and I'll show you how to do that. So first in team code, what we want to do is that we want to create a new Java class, and I'm just going to call this robot. So in robot now, so now what we want to do is we want to make a constructor called public robot, and that over here. And then what we want to do is we want to declare a linear op mode called OP. Let's name it OP for now. And then over here, we're going to put a linear op mode. So essentially what this does, and then we're going to also set OP is equal to op mode. And what this does is that when we put a linear op mode in one of our autonomous programs, it will essentially allow us to like control all like the functions. So now what we're going to do is, since we have Roadrunner installed, there's this file called mechanism drive. So assuming you have like a mechanism drive robot, like a Go Bullish Drafter chassis or a custom mechanism robot, you'll be able to control this now. So what we're going to do is we're going to write mechanism drive is equal to new mechanism drive. And right now this needs two things. So it needs a hardware map and a pose2d. So the hardware map will come from op.hardwareMap. And the pose2d, we can just put a pose2d over here. But if we want a new pose2d for every time we call it, we can also just put a pose2d over here. So pose2d, and then we can put pose2d over here. And another cool thing that you can do inside of this constructor is that you can create numerous functions. So for example, you can create a public void. Let's just call this, let's say we wanted to raise our slide, so we can just make this lift up. And then over here, we can also define a new DC motor. So for a DC motor, we can call it a DC motor, and we want to import this, so you can press Alt Enter. Or you can also just right click it. And then you can call this like slides. So in order to actually initialize this, what you're going to want to do is you want to press slides is equal to op.hardwareMap.dcmotor.get. And essentially on your driver station, you're going to like put a name for each of these like motors or servos. So let's just assume I also called this slides on the driver station. So now it's initialized. And now we can also like set direction. So for example, you can do slides dot set direction, and then like let's say I wanted to reverse it for some reason. And then I can also like say slides dot set mode, run using encoder or stop and reset encoder. Let's say I'm using the encoder. And then if I do lift up, let's say I want to do something really simple and I just want to set the slides power to 1. So I do slides dot set power 1. And right now we have like a fully functional like class for our robot. And what we can do with this now, and like let's say we also want to do like a set power like 0 in order to turn it off. So we can just say lift stop. And then we can set the slides dot set power to 0 because essentially in FTC this DC motors receive power from -1 to 1. 1 will spin it like up and will spin it so that like it goes at full power, and then you can also do like 0.5 if you want to go at 50% power, or 1 and etc., and then -1 if you wanted to go backwards. So now we have our two functions and we have our robot class. So now we're going to create another Java class, and we're just going to call this autonomous. So this will be our autonomous program. So first what you're going to want to do is you want to do extends linear op mode. And right now it's like underlined red because we don't have a run op mode function. So we're going to add that now. So we're going to do public void run op mode. And we're going to do throws interrupted. I cannot spell. Interrupted exception. And we're going to have to put parentheses over there. And there. Now you can see that that's not underlined red anymore. And inside this run op mode, what we can do is we can say our robot is robot, and we're going to give a name for this robot. So we're just going to make this maybe like my bot is equal to new robot, and we give it two things. So the linear op mode and the post 2D. So for the linear op mode, we can just put this, since it'll be like, since this extends a linear op mode, it'll be this linear op mode. And then for the next one, we can create a new post 2D, and we'll just set it to 0. So it starts like from like wherever you want. And then you want to put a semicolon at the end. So since this is an autonomous program, what we wanted to do is that we essentially wanted to do actions like one after another. We don't want it to keep looping. So like once it's done with everything, it'll just stop. So what we're going to want to do for that is we're going to do a wait for start. So essentially on your driver station, you can press init. This stuff will happen during the init period. And then when you press the start button, then the stuff after this will happen. So let's say when we start the program, we want the slides to go up. So what we do is that we just call the function that we created. So mybot dot lift up. So now this is actually a fully functional autonomous program. Actually, scratch that, not yet. So at the top, in order to actually define this as an autonomous program, you want to put at autonomous. Okay, and you have to actually be really careful about this. So the reason that this thing is so long and it has that is because we also named our thing autonomous. So in order to make this simpler, I'm just gonna like actually rename this. So how you rename a file is you press refactor and you press rename. And we can call this autonomous program. And we want to actually like refactor that. So now we can do this called autonomous. And now you can see that like all that's gone. So just be really careful of that. And now let's say we also wanted to create a teleop program, and I'll show you how to do that. So we're going to create another Java class. We're going to name this one like teleop program. And we're going to also do extends linear op mode. And essentially everything we did from the last one. So I'm just going to do that quickly. Public void run op mode throws, not spelled, throws interrupted exception. And then we also want to call a robot class again. So robot, or it's called robot, right? Yes. My bot is equal to new robot, and the op mode is this, and we new pose 2D. So you're gonna be careful because this pose 2D is actually the starting location of your robot. So let's say you wanted to start from the red side, you would want to put like that pose 2D. So we'll just put this as 0, 0, 0, 0, 0, yeah, and 0, 0 will essentially start from the center of the field, but you probably don't want that. So then once we have this, we're going to do a wait for start. And since this is this is the teleop program, so this 0, 0 will actually be for like the autonomous program instead. So now for teleop, since this is going to be going on for 2 minutes and 30 seconds, and this is essentially going to be happening in a loop, right? So what we want to do is we want to put a while loop over here. So we want to say while the op mode is active. So this is meaning while like after you press the start button, as long as the op mode is active, and you want to make sure that it doesn't run when stop is pressed. So you're going to do when stop is not, so the exclamation mark essentially means when stop is not requested, it'll also do this. So when stop is requested, it like won't do this and it'll just stop. Oh yeah, and in the autonomous program, one thing I forgot is you always want to put like a stop function at the end so that it stops once it's like done with whatever it needs to do. And while the op mode is active and stop is requested, what you want to do is you want to like do your functions. So during the teleop period, the drivers can use their controllers. So one of the functions on the controllers is the gamepad, and and the different buttons on the gamepad. So like if you've ever seen like a game controller, there's like normally an A, B, X, and Y. So let's just say the user pressed gamepad A. And if they wanted to press gamepad A, we wanted the size to go up. So we'd have mybot dot lift up. Okay, and then let's say if they pressed Y, we want the lift to actually stop. So gamepad1 dot Y. And this is a Boolean, that's why we don't need to do anything. So this essentially returns a true or false. So either gamepad A is pressed or it's not pressed. So let's say we wanted my bot dot lift stop. And then over here we want to do an at teleop, indicating that this is a teleop program. And yes, that is a fully functional teleop program, and this is like really useful. So, and by the way, if you wanted to like add another motor, you will add it into like this class, and you would like say DC motor, initialize it, and make a function for it. So like let's say we want to do multiple things, you could like put it into this function, and it would do like all those like multiple aspects. So if you wanted to keep reusing this function, you could also do that as well. Oh yeah, and you can also like use the drive since we also called that. So what you can do is so this will essentially allow you to like use like the mechanism drive in your thing. So actually we want to call this. So if you go into the autonomous program, you can do like mybot dot oh. So actually in the robot class, we wanted to make this, we should create this like a mechanism drive over here and make this public. And then you can call this a drive over here. And then in our autonomous program, we would be able to do mybot.drive, and then you can like call different motors. So let's say we want to control the left front motor, then you do the left front dot set power and some power that you wanted to put. So those are your both the teleop and autonomous programs and your robot class. So now what we're going to do is we're going to work on setting up meet. So the first thing that you want to do is that you want to create a new module. So this module we're going to call meet. And we actually want it to be Java or Kotlin library. So So the library name will be called meep, and the class name will be called meep testing. And we want to like the language to be Java, and we're going to press finish. And it's going to Gradle sync. And then once we're done, we have this main, and then we also have meep. So over here, what you want to do is that first, if we go back to here, and then we go to meep visualizer, want to follow the instructions on this page. So we already did this new module, and we went to Java Kotlin library and put in the application name. So then from here, we put the name, and then we want to open up the build.gradle file and change our version 1.7 to 1.8. So we will do that now. So look for meep and build.gradle 1.7. So it's actually already version 17. So that should be fine since this is 1.8. And then at the bottom of the file, we want to add this limit. So we should just copy it. And then over here, we will add this. And then we will Gradle sync it. And then this is the code for the class. So you can just copy this code. And I'll also include the link to this thing in the description if you were wondering. This is just github.com acme robotics/meep. So over here in our meep testing class, we can just Control A this, and then we can do this. And this is meep, so we can just change this to meep again, and the file name's the same. So this is good. And then that is good. And now I'll show you how to actually like run this. So first in team code, we want to go to edit configurations. And then we want to press the plus button. And we want to create a new application. Application is over there. And we will call this meep testing. The module is not specified. So what we're going to want to do is you want to like include like Oracle, but when you click this, it will find it. So meep would be, then the main class would be yeah, so in this you actually want to put the FTC robot controller master meep.made, and then over here will be com example meep testing. And this should be good. So just press apply and then press OK. And now you'll see you have two. So when you want to download on the robot, you want to click team code. And then when you want to run meep, you want to click this. So now this will just do like the basic code that's here. This is the code that like came with it, but then I'll teach you how to make your own path. And you also want to make sure this is the correct field. So this is actually the like 2022 to 2023 game. And then obviously we're gonna have the 2024 to 2025 game, but the season hasn't been released yet, at least when I'm recording this video. But our latest game was center stage. So we can do field center stage if we want to see like the latest one. And then yeah, this is ready. So we're just gonna press the run button. And when you run it, you'll get something like this. And you'll see the robot is going in a square right now. So now, like, let's say you wanted to make your own path in this. So we'll just close this for now and go back over here. So we have this thing called RR Pathogen that was created by a team. So shout out to them. And it's just like, we found this really useful. So in order to download this, you want to go to the releases page. And then you want to do the latest one. So you can just click the jar file, and then in order to open it, you would just press, like, once you have downloaded it, you can just open it. It will be called R pathogen. And then you'll get something like this. So what this allows you to do is you can actually just draw your own paths. So like, let's say this is like probably like not realistic, but let's just say we wanted to make a path that goes in like a really big square and like maybe diagonally, and then maybe an X, Yeah, you can like have fun with this, and then this is also really useful for autonomous paths. So like let's say I wanted to like make something that goes like this for like the previous year or something. But you can just draw a path like this. And then what you want to do is you want to press export and then copy the clipboard. And then you can go back to Android Studio, and over here, like right now, just paste it. We need to like do some editing on this program. So just paste it over here and you will see a lot of like red lines and stuff. So what you first want to do is this is a vector 2D, so just press Alt Enter in order to import this, and that will go away. And the first thing you want to do is you want to copy this pose 2D that's over here, copy it, and then you want to paste it over here where it says like 000, and paste it over there. So this is the starting location of where the robot's going to start. And then you want to like copy all of this over here, or cut it, and then you want to paste it in between where all these like line 2x stuff is, and then just paste it over there. Then you can just delete this since we don't need this anymore. And then you can run this program. So just press the run button again, make sure you meep testing. Okay, mine opened on my other screen, but as you can see, the robot is following the path that we created. Yeah, so actually it went off the screen. So yeah, as you can see, my path is also off the screen. So make sure it actually stays on, or when you actually like run this program in real life, it'll like hit a wall. So yeah, that's it. So for like this presentation, and we tried our Pathogen and created the new code. So if you have any questions, you can contact us. We're team 19862 Mecha Mantises. We have a Discord server, which we highly recommend that you join if you have any questions. And then we also have our email, website, and Instagram, and you can like take a picture of this. And thank you for listening to our software kickoff, and I hope you have a great season.